Our next presenter is an instructor and author for Pluralsight. He is an international speaker and creator of the open source testing tool Approval Tests. His name is Llewellyn Falco. The title of his presentation is Zero-Day Bugs and the Risk of a Long Deployment Cycle. Stage is all yours, Llewellyn.
Thank you. So hello, everyone. Yes, I am Llewellyn Falco. As mentioned, this talk, there's a lot of resources with it. So I give you a link here with all of them. I will give you this link at the end of the talk as well. But let's get into it. And before we do, I want to pull out a problem I've noticed in programming in general, which is the way we model the world internally in our brains is based on the physical world. But the programming world is the virtual world, and there are different rules. And because of that, we model things based on the physical world, and then we take those same learnings and paradigms to the virtual world, and we expect them to uphold, even though the underlying assumptions are no longer true. So in the physical world, reliability has a track record. So if you have a choice, you're going to get on a plane. We're almost at the end of the conference, so when you are returning home, if you had a choice between a plane that has been flying consistently 9 years without any issues versus a plane that just got a new engine, most people want the thing that's been reliable, right? It's been flying 9 years without an issue. It's going to fly 9 years in 1 day without an issue. But that new engine, maybe they installed it wrong. So we have this idea that stuff that hasn't been a problem is safe. And so we take that to the virtual world, and we look at a server that's been in production without issue for 9 years, and that's not something we have to worry about. What we need to worry about is that new release that just came out. And so to tell this story, I need to take you way, way back in time to September of 2013. This is back when Bitcoin was just $133. And way, way back in September of 2013, Log4j released version 2.0 beta 9. And this Log4j included a feature that allows for string interpolation. Right? Java itself does not. If you're used to other languages, most other languages do have string interpolation, but Java does not. And so they gave us this way that we could say something like, hey, I want to log the Java version. And instead of it printing Java version, it would actually figure out like, what is the Java version? And it would put it in there. And that was really nice. It was convenient. It was much simpler than what you would have to do in actual Java, given that it doesn't have string interpolation. And so basically people were happy. And they're recreating sort of a language feature, right? So they have to do like some parsing and stuff, but they made it really robust, right? Handling stuff like uppercase and lowercasing, so you could like format stuff or dates, but also pulling out information like from your maps or your Docker environment, or just your environment in general, your events, stuff from Kubernetes, stuff from servlet context. All this stuff allowed you to just really easily log. But unbeknownst to basically anybody, there was a small bug in this thing way back in 2013. Log4j became one of the most popular logging platforms out there, and Java, one of the most popular languages in production. So this was very ubiquitous. But October came, and Adobe actually got hacked pretty hard, right? 152 million records were taken away, people's usernames, passwords, their password hint. It was pretty bad, but not Log4j. Log4j was great. Next year, in September of 2014, Home Depot got hacked. 56 million records. Right? A lot of credit card information in that hack went away. But not Log4j. Log4j was great. They actually released a whole bunch of releases. They're up to 2.1 at this point. Everything's going good. That little bug, not discovered at this time. Next year, Ashley Madison got hacked. 32 million people who were seeking an affair. A whole bunch of very devastating information presented. Credit card names, full names, what they were looking for in their affair. But Log4j was absolutely fantastic. No problems at all, super reliable. Released up to version 2.5. Next year in 2016, Uber got hacked. 57 million records were taken there. Lots of information, but also Uber's GitHub account got hacked, right? So not only did their customers suffer from this hack, but the company directly took a hit as well. But not Log4j. Log4j was great. 2.6, 2.7, just cruising along, super stable, nothing could be wrong. The bug that was written way back in September of 2013, still undiscovered, and Log4j's popularity just continuing to rise. In 2017, Equifax gets hacked. 148 financial records taken. Social security numbers, driver's license, birthdays. It's a very bad hack, right? Ironically, from a known vulnerability that they hadn't patched for a couple of months. But Log4j, no problems at all. They released another bunch of versions. They're up to 2.10 now. Absolutely solid. What could go wrong with logging? 2018 was a kind of busy year. Marriott got hacked, Twitter got hacked, Quora got hacked, a whole bunch of emails, passwords, birthdays. Also, because of the nature of hotels, a whole bunch of corresponding loyalty programs for the airport. A total of almost 500 million rows. But Log4j, no problems at all. 2.11 comes out, it's cruising right along. We go another year to April 2019. Facebook gets hacked. 146 gigabytes of information, which got published to the dark web. You can just download this record set. Again, about 500 million rows. But Log4j, absolutely no problems, right? Releases another 4 versions and is safe, trusted, ubiquitous. March of 2020, CAM4, the world's largest data breach, occurs. 10 billion records. That is more than the number of people on Earth. Tons of information coming out in this one. Emails, payments, a whole bunch of correspondence. But again, Log4j, absolutely no problems. They released another 4 versions, completely stable. A year later, October 2021, we're now 9 years later, Twitch gets hacked. A fairly small number of records on this one, but took the source code from Twitch. It took the payout reports for all of Twitch's streamers. And rather embarrassingly, it took Twitch's internal security training, right? Which is just embarrassing for their security team. Log4j, though, no problems. Releases one more version, everything is good. This is October. In November of that year, someone realized that string interpolation, if you use JDNI, JDNI was on that list, but nobody was really using JDNI. It's just sort of an obscure way of doing distributed computing, we used to think about it a lot for distributed computing, but then microservices came out and they're just so much better and easier. And JD&I sort of fell to the side. It's still used by a couple people, but basically nobody uses it. But whether you were using it or not, Log4j supported it. And so if you would put this string in, and in almost every website, if you just put bad parameters, what the website does is log those and then kick you to some sort of error page. But in the logging of those, what this would interpolate to was say, let me look up this LDAP address, take me to this other server. It could be any server, any URL you put in. So I'm going to go to HackerNow. I'm going to grab this piece of code, return the bytecode of it, and then execute that code on your server as your server permission level. Now, this piece of code right here will simply rickroll your server. But obviously you could do horrible, horrible things and basically anything you wanted to that server you were compromising. And any server that was using Java was pretty much logging any invalid response. Meaning almost every server was all of a sudden very, very vulnerable. This was reported to Apache in November. They sat on it for a couple days before announcing the fix. And that answers this question, like, if a patch for security vulnerability was made available today, how long would it take till your projects were no longer vulnerable? I mentioned Equifax got hacked a couple months after the patch for their vulnerability was known and fixed. They just didn't fix it at Equifax. So the question is for you. All you have to do is update a dependency. That's it. How long would that take for you to do it? And this begins our 4 tales of terror with Log4j. Let's start our journey, because our journey begins with my team. Now, I am a very big believer in software craftsmanship. And so our team was doing refactoring, it was doing unit testing, but more importantly, we were doing continuous integration and continuous delivery. And so the way that this needs to resolve is when Apache announced to the world that this vulnerability existed, they also did it with a new release, version 2.15. And 2.15 solved the thing. Basically, no one was using JD&I, so their patch was pretty simple. They just said, by default, JD&I is turned off, and you have to actively turn it on. So they released this, and now the process basically goes, someone needs to notice that it gets released. They need to upgrade our system, create that pull request. We need to know, hey, does that pull request, is it good? Does it work? And if it does, we just need to merge it, and then we need to redeploy. So that's the process that needs to occur on my team. And let's look at how it occurred on my team. So the first thing is someone notices. Somebody, in this case, is not an actual person. Right? We are using a Dependabot. Right? So we have a small little piece of YAML. It's only 6 lines sitting in our GitHub repo that just simply says, we use Maven, right? The most popular ecosystem for Java. And here's where we're located. And just anytime you notice that there's a new dependency, let us know. So Dependabot is the thing that noticed. It submits a pull request saying, hey, I want to bump log4j from 14.1 to 2.15, right? And you can see right here, did it immediately. Right? The nice thing about computers is they're really good at repetitive tasks. So now I need to know, does it work? But like I said, I have continuous integration. So I can simply look at my badge and I can say, yeah, RCI passed. All our tests passed. The new version, not a problem. So now I need to merge it. And again, merge it, that somebody is not a person. We've added a little piece of code to our CI that runs our tests that simply says, hey, if this is a pull request and it is given by Dependabot and all our tests pass, well then automatically merge the pull request. So we receive the pull request automatically from Dependabot. That kicks off our build, which tells us, hey, new version works fine, which then says, hey, since the new version works fine and Dependabot told us to upgrade the version, we're going to. And then we have a CD, or a continuous deployment server, that just automatically deploys that to production. Meaning this entire process, it was less than like 3 minutes and no human was involved. So at this point, my server is fixed, but I am not even aware of it. Seamlessly, on the day, it's immediately handled. Because it worked, and everything else was automated. But that brings us to the question of what happens if it didn't work. And for this, I need to talk about Oliver. Oliver and I had a meeting set up that morning. And so I was actually calling him for the meeting, and he was in a panic. And I did not understand why. So he's like, hey, have you heard about this Log4j thing? And I had not, I had just sort of woken up. But I checked our things and I'm like, oh yeah, it's been patched, it's already fixed. And he's like, well, it's not patched for us, I need to cancel the meeting. And I was like, that's okay. But let's not cancel the meeting. Let me just come and join your team and I'll help you get through the Log4j problem. And he was like, okay. And just a little context on Oliver's team. They were doing 1 month sprints, right? Which is a fairly common way of doing a Scrum. I prefer the 2 weeks if you're doing Scrum, but you know, different teams, different things. They would release on the 15th, so mid of every month is when they did their release. And this was the 9th, so 15th is actually not too far away. And so I made this diagram, right? But there's a third case that I had not considered, which is not that it works or it doesn't work, but just simply they don't know if it works. And you might ask, like, how do you not know, right? Like, does it compile? Do your tests pass? And those things do work, but the issue for them was that because they were doing these 1 month releases, they had built up 3 weeks of commits. Features that had been built. Right? Some of these were bigger, some of these were smaller, but lots and lots of work had been done. And this was the part that they did not know if it worked. And this is why, when I asked, like, can we just ignore that? Oliver was hesitant. He said, you know, we're going to have to take the server down in the middle of the day. It's not something we normally do. Normally we do our releases at night. So we're going to have to break production, and I really would prefer not to do that twice if we need to. Right? So he was hesitant to throw away the work. So my question was sort of like, is there someone who knows, can we just release a week early? And the answer to that question was yes. Abby knew. And so we brought Abby in. Abby was in charge of testing. And we sort of explained the situation to Abby. And Abby has a really good understanding of the way that this system works, like its vulnerabilities, its issues, its history. And so she had a very clear and concise answer to us. No, you cannot release this stuff. Testing never goes smoothly on this team. You're like, there's no way we can rush this release. That will just make things worse. And so we decided, hey, let's go and do a patch release, right? Like, so we're going to take the old work from a month ago, apply the log4j fix, and re-release. And that process, on a good day, it takes half an hour. On a bad day to release, it takes like 2 hours. This happened to be a good day. We got stuff, we got it released, and by lunchtime, we were done. Lunchtime is not too bad. It's obviously not nearly as nice as my scenario, where it was immediate, right? So it was a smaller window of attack, but we survived it. But I learned something from that, right? Which is like the importance of minimizing your work in progress. This would have been a much easier conversation if we didn't have to worry about throwing away the 3 weeks of work right now. But because we had so much currently on our plates, we are just hesitant, right? It's only half a day of hesitation, but it'd be nice not to have it. So if you don't have a lot of work in progress, you can always redeploy if you need to. But either way, it was only half a day. By noon, they had deployed the next one, and they went to lunch. I went to lunch. Oliver actually went to lunch with Sophia, who brings us to team number 3. Now, Sophia was having problems with Log4j and notably stressed out. So Oliver suggested that she talk to me as well. And I was kind of surprised because I knew Sophia and I knew that she actually cared about software craftsmanship too. I knew they were doing continuous delivery. So my initial thought was, why did your dependent bot not fix it the same way my dependent bot fixed it? And the answer to that question is that they were not using dependent bot. So they were doing continuous delivery, and that part is great, but they weren't keeping their dependencies up to date. And so when you ask this question of does it work, the answer was no. When they pull the latest version, it doesn't work. And the question is why? And especially with Log4j, the question is weird because Log4j is not a very complicated API. It's weird that it wouldn't work, that you couldn't take the latest upgrade. And the truth is, from Sophia's team's perspective, they basically weren't using Log4j. I mean, they were, but they also weren't, right? The way that their system worked is they had another dependency they used that used Log4j. But that dependency would log all erroneous parameters. And so they were just as vulnerable as everybody else. And you know, for the purposes of this story, I will just call this some technically relevant ubiquitous tooling solution. That's what they were using, right? I'll abbreviate that as struts. And so they were having problems with this tooling solution that they depended on that used Log4j. And they were not on the latest version of that tooling solution. And it turns out there were actually quite a few upgrades that caused trouble, breaking changes with their system. But we did not know this at the time. All we knew is that if you went to the latest version, you got in trouble. And so we effectively did a manual dependabot on their system, which is to say, we went back and we started upgrading just one level at a time, right? Just bringing them up through history. And this is many years back, so we had quite a lot of versions to go through. And when we got to our first one that broke, we gathered around as a team and we figured out what was it. Now, some of that was just like, hey, look at the compilation or something like that. Some of it was reading the old release notes. Hey, when they released this version, did they tell us what broke and how to fix it? Some of it was like just normal Stack Overflow stuff. And some of it was simple, right? Like little changes, and other was more structurally weird changes. But either way, we'd figure it out. And then it was usually ubiquitous in their code thing. So once we'd sort of figured out how to do it, where we felt like, okay, the team gets how to solve this, we would split up and everyone would go and get all the places as possible and we would just fix them all. And then when that was done, we would repeat the process, continue upgrading version until we got to a failing one, gather again together and figure out how do we solve this new paradigm change. And then we would, once we figured that out, we would break out again and we'd go to all the different places and we would fix it. It took us about a week to do this, right? To catch up with the past. And what I learned from this is that, because I'd always thought of technical debt as just sort of messy code, right? And I don't like technical debt, and I do a lot to get rid of it, but I hadn't thought of technical debt as previous versions. I should have. I've actually been at companies where they had to scour eBay for old printers because new printers won't connect with the version of the OS that they are still using in production. These are large, multi-million-dollar companies that are still dependent because they need an LPT1 port. It's crazy. But it's common, right? You end up on a previous version and it doesn't allow you to go to the current version. So if something goes wrong with those previous versions, you're a bit stuck. Right? Simply said, you just can't upgrade if you can't upgrade. But like I said, this took us about a week. It took us about a week to upgrade all the dependencies, get that thing. That was a very stressful week. And at that point, I figured it must be done. Turns out I was wrong about that. And in fact, a report showed that even today, something like 30% of sites that use Log4j have not upgraded and are still vulnerable. That is insane, right? We are months out. But at my company, there was one more place we had to deal with. And that brings me to Alex's team. Now, Alex's team had not deployed for 13 months. They are part of a very core part of our system. And you might ask, how can a core part of our system not deploy for 13 months? But, this was an old piece of the code. And as such, most of the important bugs had been fixed years ago. Now, there was a lot of improvements that they wanted to make to this that was almost impossible to make, to the point that they decided they were going to do a rewrite. And so they had sort of sketched out a rewrite. It was going to take them sort of 8 or 9 months. That estimate turned out not to be right. # no estimates. And they were now 13 months later. And the rewrite was nowhere near the place that they could turn off the old system. So we needed to fix and patch the old system. Now, I had already learned from Oliver's team that the way you do this is you just redeploy exactly what was in production before. Don't worry about any fixes or any work in progress. Just throw it all away. Go to where you were, redeploy it. So I thought, this will not be an overly hard thing when I came to Alex's team to help them. The question is, does it work? And the answer was actually yes. They were using Log4j directly, right? So all we had to do is merge it, no problem. And now we just need to deploy it. That was the problem. So the first question is sort of like, Who deployed it last? Well, like I said, this was a rewrite. And all of the previous members of the team were no longer with our company. They had moved on to greener pastures. So we did not have access to a single person who was part of the deploy previously. That's not necessarily a problem, right? You can still follow the docs, run the scripts, right? So let's just redeploy. But it turns out that was not easy either. It was a very manual process. There were no scripts to do this. So we did not have any records of how you deploy. And to make the system slightly worse in this case, AWS had retired the service that we were using. So we couldn't just redeploy. But you don't need to necessarily redeploy. Really, we just have this one jar file. We just need to upgrade this one jar file. We could go onto the server and we could take the old jar file and just replace it, upload the new one, and Bob's your uncle. We're all good. We just need to update the server. Well, funny story. Security was really important to this team, so they obfuscated the code on their servers. So if somebody did hack into the server and get the source code, they couldn't do much with it. I feel like if someone's hacked your server, you have bigger problems than the source code. But they were correct that they would not be able to do anything with it. We were not able to do anything with it. We explored this for a while before realizing that even if we could figure out what the calls for log4j were that we were trying to replace, we couldn't re-obfuscate log4j in a way that would be compatible with the way it was obfuscated before, right? It's not a deterministic path. So we were a bit stuck. These were long and horrible days. They often started bright in the morning and they went late to night. And this took us an entire month before we finally saw it. And we were being actively hacked, not just actively hacked by foreign governments, right? We had attacks from North Korea, we had attacks from Iran, right? And we were just helplessly watching as we were getting hacked. But what we finally figured out is that while we couldn't update any of the code, we could basically block all outgoing calls. So if you remember, this particular hack happens because it makes a call out to another server, grabs some code, and then pulls that code back to your local server and executes it. So if you can't get out, then there's no attack. And so what we ended up doing to solve this problem was block all outgoing attacks. We were still getting hacked. We were still using bad, vulnerable software, but we basically neutralized the effect of those attacks. And this was a little bit of a trial and error process. We didn't exactly know all the places this source code was talking to that it actually needs to talk to. So we started with sort of a whitelist and said, you're only allowed to talk to here. And then the site would sort of break a little bit. And we very quickly be like, oh no, we actually do need to talk to that one. But it wasn't horrible. We got through it. Took us about a month. And the main takeaway from this is just you have to be able to redeploy. If you cannot redeploy your software, your server tomorrow, you are dead in the water when someone realizes that the source code you've had in production for years is unbelievably broken and vulnerable to an attack. That's what a zero-day bug is, right? It's the bug that no one else has known about yet, so no one else can fix. If you're of the black hat community, you can use that to attack servers, or you can sell the zero-day hack to other people who want to use it for a lot of money. If you're of the white hat community, you can report it to Apache or whoever is the system so they can fix it before everyone else gets compromised. But there are a lot of zero-day bugs. Log4j is just one of them. One that worked in a very, very popular logging framework for 9 years, sat silent before someone discovered it. 9 years is a long time. You absolutely, every server you have has a very bad bug on it that someone just hasn't discovered yet. And maybe that's at the Java level or there's whatever language you're using. Maybe it's at the OS level. There are lots of zero-day hacks that occur at Linux, meaning even if you can redeploy, but if you can't recreate your server from scratch, you're in trouble. And we come back to this, which is safer. That server that's been in production for years without any issue, or that one that we're constantly redeploying? And the answer is it's the one we're constantly redeploying. Because the world changes underneath you. Goiko mentioned this way back in 2018. This is a lovely tweet. Software development 2008. Your code you didn't touch doesn't break. Software development 2018. Code you didn't touch breaks all the time. Welcome to the cloud. Yeah, that's the world we live in today. You do not have to touch something for it to break. So the longer it's been since you deployed, the larger the liability to your company. If you have a server that you haven't deployed in a couple months, that is your liability. If you haven't deployed in a couple of years, it's a huge liability. It's the exact opposite of what, most of the time, those are the things we don't even pay attention to, we don't even consider. But those are our big problems. And it's the reason why like services like Chaos Monkey, which will just randomly turn off servers, because the way that like brains work is if something only happens once every 5 years, we basically think it doesn't happen, right? So the idea of Chaos Monkey is to say, well, let's make it happen frequently so we can actually handle it when it does, right? Let's turn up the bad, or the way we say it in Agile is if something hurts, do it more often. But Chaos Monkey will actually preference servers that are older. So the longer a server has been alive, the more likely it is that Chaos Monkey will turn it off. And if you're in that situation, like Alex's team, where you have this just huge monumental thing that you have to handle, the way you solve that is by very narrowly focusing on the first step. And what is that first step? It is always, if you haven't redeployed, redeploy every month. Don't let any of your servers be more than a month old. If you did it last month, you can do it again this month. And so these are the two questions I want to leave you with. How old are your servers? This is a chart that every manager of every company should know. And it is something that almost no managers know. Know, A, what servers you have in production, and B, how old they are. When were they last deployed? And preference the ones that haven't been deployed for a long time. Those are the ones that you have the biggest vulnerability with. And then a separate but equally important question is, how old are your dependencies? Again, you can't upgrade if you can't upgrade. As I mentioned, there's a whole bunch of extra resources. Here's that link again. And I'm Llewellyn. Thank you very much.
Thank you, Llewellyn. Wow, that was a really interesting presentation that you gave. I, as a non-technical person, was captivated by this whole redeploy your servers and fix things, dependency. So it was quite interesting. I'm looking to see if anybody has posted any questions in Slido. I don't see any at this time,
Oh.
Llewellyn, but I encourage all our viewers to write into Hopin or Slido, and Llewellyn will get them and he'll answer them for you, or you can reach him. I think he's got you on here on Twitter, LinkedIn, anywhere. So
yeah, internet unique name makes it easy to reach out.
Yeah. So with that, actually, we're out of time. So I'm going to say thank you very much for your presentation. It was really interesting. I didn't realize that, one, I think it seems to me that servers are pretty easy to break into.
I mean, it's surprising how many of these zero-day bugs, when you look at them, they're completely non-obvious, and yet they're devastating. Right? And I think that's why they sleep for so long. Right? They just sit there sleeping until one day they get exposed.
I see. So there you have it. Have a look at your servers, redeploy them, look at those dependencies. And with that, I'd like to say thank you again, Llewellyn, and
Thanks.
Enjoy the rest of your day.
Yeah, have a good afternoon.
Okay, bye-bye.